to the introduction to Azure Machine Learning. So today I'm going to do a workshop on Azure Machine Learning. And I'm Nelum Weerakoon and working as a tech lead at 99X. And so today's content will be I'm going to give a basic introduction to AI. I hope that most of you already know, but I will go through it first, and then introduction to machine learning and covering up several different aspects and certain areas, and introduction to Azure Machine Learning. And then I'll do a demo, a workshop on Azure Machine Learning and Machine Learning Studio in Azure, and then we can have the Q&A session. So starting with what is artificial intelligence? So basically, artificial intelligence is imitating the human behaviors, the software that imitates the human behaviors and capabilities. So mostly the cognitive abilities of a human that software can imitate, and some capabilities like functions. So that is what we call artificial intelligence in some terms. There are certain other definitions as well. And when it is come to artificial intelligence, there are a few key elements that we should know about. So these are the key elements. So machine learning, anomaly detection, computer vision, natural language processing, which we all know as NLP, most of us, and the conversational AI. What is machine learning? Machine learning is it's kind of the basic, the foundation of most AI solutions. And it is basically making the decisions and predictions based on data and experience, based on data and past experiences. And anomaly detection is identification of unusual activities in a system. So if there are any outliers of certain systems, that's what we call anomaly detection. And then computer vision, it's about detecting, recognizing, and analyze visual inputs. And the natural language processing is basically understanding of written and spoken language. So the natural languages understand the computer software understanding the written and spoken language is called natural language processing. And the conversational AI is kind of bots that we are using mostly now. A software agent engages in intelligent conversations and dialogue. So you might have already come across these AI bots and certain agents that where we can start up conversations and banking assistance. Those kind of things we call conversational AI. And when it is come to AI, when we are developing an AI system, there are some risks and challenges come along with them. So these are some common areas that we have to look into. So when we are developing an AI system, we should be aware of these risks and challenges. So they are the bias can affect results. There can be certain system can be biased on certain things and it can affect the results. So, and the other one is errors may cause harm. So errors in the sense, let's say that there are some auto driven vehicles now like Tesla. So if there are errors in that we all know that it's an AI system, and if there is an error that it can cause harm to humans. So likewise, when we are developing an AI system, we should be aware of these things, and data could be exposed. So we should be aware of the privacy of data, and so data should not be exposed at any means, and we should be very careful about that. We should go ahead with the police policies and rules. Solutions may not work for everyone. So when we are developing a system, it should be for everyone. So it should cover all the aspects, and if we are doing any exclusions, that should be uh, with a purpose, and we should mention it. So I'll discuss this more with some principles that we have to follow in the next slide. So that is another risk that we are facing. And users must trust a complex system. AI systems are not simple. So they are very complex system most of the time. And when we are given a system that users trust it, and if they are giving us the trust, we should keep it. So that also one part that we have to look into. And who is liable for AI driven decisions, the accountability. So those are some risks and challenges coming along with AI. And if we see in Microsoft, they have introduced that there are 6 principles that should cover all the risks and challenges that we discussed in the previous slide. And these are the 6 principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. What is fairness? Fairness is it's AI solution. It should guide the AI solution to treat everyone fairly with no bias. So it should reduce the unfairness. It should be balanced, properly balance the representation. This is called socio-technical challenge. So we have to balance the representation, and it should be fair to everyone. So let's say that if a system is biased towards the gender, or maybe uh, based on some roles, and it's not a good system. So every time that it should be fair, and we should develop a fair system. And then reliability and safety. It guides AI solution to be reliable in operation, to resist harmful manipulations, and be safe for the users. It should well understand the risks and well aware of these risks. If there are any risks associated with the AI solutions that we are building, because we are giving the power to a computer to do certain um, decisions, to take some decisions and carry out the functionality. So because of that, it should give the it should identify the risks and challenges carefully, and it should be well aware, and the system should be developed and make sure that it resists harmful manipulations, and the system is safe. So for an example, that Tesla car, when we are developing something like that, we should be very careful and minimize the risks that can happen. Privacy and security. What is privacy and security? So we use a lot of data when it is come to AI solutions, that most of the time we need data, some past data, and also when it is come to computer vision or something, that we need data of the images for that. So we have to be careful about this data, and the data should be secure, secured, and follow the privacy principles. We should ensure the data is protected. The data protection should be ensured. And inclusiveness. Inclusiveness is when it is come to AI solutions, it should provide benefits of solution to everyone with no barriers and limitations. Solutions should follow 3 inclusive design principles. There are 3 inclusive design principles: recognize exclusions, solve for one, extend to many, learn from diversity. So if there are any exclusions, it should be mentioned and clear to everyone why they are not included into this particular AI system. Okay. Then transparency. Transparency is that, as I mentioned before in the previous slide around about the risks, that users trust this system, and if they are to use this, they should have the transparency. What this solution give us, what this solution provide, the full information of the system, what the system, what are the operations of the system, and the behaviors and the limitations. These should be properly informed to the users to get their trust, and we have to be very transparent on them. And then the accountability. So this is the guideline to get the AI solution to follow governance and organizational norms. How technology impact the world. And for an example, there there are facial recognition. When it is come to computer vision, that facial recognition is one of the key part. And because of that, if some person can be moved into a threat, that should not be happen. So whoever developing the AI system should take the accountability of the system and make sure no harm would happen to anyone because of this system. So these are 6 principles that mainly Microsoft focus on when the developers are developing any AI based systems. Okay. So I'm moving into the next part of this workshop. So it's the what is machine learning. So what is machine learning? Machine learning is it can be a software or a system that builds and trains models based on the input data to predict an outcome. It's a system or a software that builds and trains models based on the input data to predict the outcome. And if you all can see that this is an example, so there are some flowers and we have identified some labels for I mean features of these flowers and given train the model, and then when we are given another flower, the system should be able to understand what what is the um, type of flower it is. So let's go to the next one. So machine learning, there are 3 main groups for machine learning. That is supervised group, unsupervised group, and reinforced group. What is supervised group? In supervised group, there are 2 categories. So supervised group is make that in the supervised group, we make predictions based on the information from the previous outcomes. So it based on the previous data that we are given a prediction. It relies on structured data. In the inputs will be fields or columns, which are called as features. So it is based on structured data, and this has fields or columns, and these are called features. And the output is called as label or labels. It can produce a label or set of labels. So as I mentioned, there are 2 supervised models, that is regression and classification. I will explain about those in later slides. And then unsupervised group. What is unsupervised? Makes prediction without any prior knowledge of the possible outcomes. There is no prior knowledge. There is no previous data. So we have the set of data that we should analyze, and based on that, we categorize, like cluster them into different groups, and then give the prediction. So there, this in this unsupervised group, we don't have a prior knowledge of the possible outcomes. Reinforced group, it learns from the outcome and decide the next move based on the knowledge. In the reinforced group, that it learns from the outcome, and the next move will be decided based on the previous move. Okay, let's see what is regression. So regression, as I mentioned before, it's a supervised learning group. It's a supervised learning model, and it produces a numeric value prediction for the labels. It's mainly for the numeric values. The regression is used for numeric values like game scores, stock prices, and so on. Concept of having computer to find the relationship between an understanding and come up with some idea to identify some patterns. It's a concept that computer find a relationship between some data and getting an understanding and come up with some idea to identify the patterns. So it's mainly rely on the structured data, and input fields are called features, as I mentioned before, and the output calls as labels. So it identifies a correlation between a feature and the outcome. It's better to have more data as possible to take a good possible to cover possibly cover the whole set of data should cover to get a good prediction. So in this data set that we normally separate the data into two parts. So that is called the training and validation set. If we have a, a set of data, so normally it's good to have at least 70% for the training and 30% for validation, and it should not be random. So when we are selecting a part of the data set for training, it should always be cover all the scenarios as much as possible. Then only we would have a proper model to predict predict any other data sets that we are getting. So the separation should not be random. It should be carefully selected. And then classification. So when it is come to classification, so classification is also a supervised learning. It predicts a class or multi-class of label based on incoming data. So it can be classifying a picture as a dog or a cat. It's mostly a positive or negative answer, 0 or 1 answer. So rely on structured data. This is also rely on structured data. As mentioned before, it's also called features. The input fields are called features and outputs are called labels. Yeah, negative and positive identified. And for all these things, we need at least uh, a set of data which covers all possible scenarios that we need to have. And then clustering. Clustering is an unsupervised learning model type, as I mentioned before. It predicts what data points belong to what cluster or the group. So there is no prior knowledge, but based on the properties, the common cluster properties, it learns from the common cluster properties and then calculates the cluster membership probability for each data point. So if you can see that they start like this and then move on and calculate in each point and then find the proper cluster. That's how it goes. Um, yeah, so we know that it uses k-mean algorithm for this clustering purposes mostly. And data points as close, the data point should be close as possible to find. So then only that we can satisfy that these data belong to one cluster. And so we should keep iterating to find out the closer relationships, and it should be accurate, and then find the smallest variance between the data point. That's what we concentrate on clustering. And then uh, we'll move into Azure Machine Learning. Azure Machine Learning is a cloud-based platform for ML. So when we are working in Azure Machine Learning, we should have a subscription on Azure first. And on that, we should create Azure ML workspace, machine learning workspace. And we should have a compute to do the computation work. And then we should have data set. And then we have models in there, and we can use these models to come up with the experiments, and then we can deploy it as a service. So that's how Azure works, Azure ML work. And there are four main features in Azure Machine Learning. Automated machine learning. This is for feature enables non-experts to quickly create an effective machine learning model from data. And then we have Azure Machine Learning Designer. It's a cloud-based storage and compute resources that professional data scientists can use to run data experiments, code at scale. And then we have pipelines. For data scientists, software engineers, and IT professionals, anyone can define pipelines to orchestrate model training, deployment, and management tasks. And then we have data and compute management. It's a cloud-based storage and compute resources that professional data scientists can use to run data experiment code at scale. So these are the main stuff. Okay. Uh, Core tasks for building machine learning solutions. So when these are the core tasks that we have to do when building a machine learning solutions. So we have data ingestions. So we have to inject the data first, to bring the data from different sources into a common repository. And we have three ways to do this: upload a data set, manual input, or import data. In Azure, we can inject data using local files, data stores, web files, open data sets. And then we have to prepare the data and transform the data. In the data preparation and transformation, what we do is find and correct errors. We can find and correct errors, and we can remove outliers. We have to find and remove the outliers and impute missing data. We can uh, update the data with missing, if there are any missing data that based on other data, that we can update it, and with appropriate values. And then we have the feature selection and engineering. In the feature selection and engineering, we review the data before training the model. Selecting features, and we have to select the features that influences the prediction and discard other features from the final data set. So we have to include only the features that should be influence the final outcome we are expecting, and remove the other um features from the final data set. And bring the value to a common scale. So bringing the value to a common scale is if we are having numeric values like 0.5 and some are 500, we have to bring them into a common scale. So we can multiply the 0.5 by 100, that column by 100, and get them into a common scale so that all the columns are in the same scale. And we can generate new features. Generate new features based on the existing features. So we can combine two features together and generate another feature. Likewise. And then we have the model training. And in the model training, we separate it to two parts. As I mentioned before, the training set and the validation set. Then we have the evaluation. Evaluation means that we need to score the model with test data. So we have trained the model, and then we have the test data. By running the test data, we can evaluate the model and get a score for the model. And then we can deploy the model if the model is satisfactory, and we can deploy it and use it for other services. And then model management. It's kind of a principle from DevOps. The model management is principle for DevOps for model maintenance and machine learning operations. It's called MLOps. So it creates a reproducible environments, code management, and package deployments, monitoring and alerts, those kind of things. That is called MLOps. Okay, so automated machine learning, it provides data and the desired model type, then let the Azure machine learning to find the best model. So in the automated machine learning, we give the data, and then we select the models, and then let Azure machine learning to find the best model for the given data. So I'll do the demo now. If I move into Azure, so when we are create, so as with this might take a little bit of time, I have already created certain things, but give you one more thing. Sorry. So when we are creating an automated machine learning, we have to first have a resource group. So this is being created because as it might take some time, I have created this. And then create a workspace. I will show you how to create a workspace. And then launch the machine learning studio. Then we have to create a compute instance, create a cluster instance, and then create a data set. And then we can do the model training. So if I go to this, um, so I hope that you all might know how to create the resource group. So I'll show you one thing like, so machine learning is there in here, but if we can find it by going to the all services and type machine learning, and we can select this. So I have created this, but I'll show you in another instance. I'll show you how to create that also. So we can, so here we can create a resource group here as well, but if you have an already created, we can have it. And I tried with Asia, Southeast Asia, but it didn't work. So I will choose one of this Europe because some of the computes are not available for Southeast Asia. And so we have this. We are creating this workspace. So once a workspace is created, we can go to that. And in here, you can see that launch video studio. So when we launch the studio, it directs you to the Azure Machine Learning Studio. This is a created uh, workspace. So in here, first we have to create a compute. So before that, I'll show you one more thing. Like if you go to home, so there are three main solutions that we can use under Azure Machine Learning, as I mentioned before. So there are automated ML. That is what we are going to, I'm going to present today, a demo today. And there's a designer that we can do drag and drop interfaces for data. And in notebooks, if you know how to write algorithms on machine learning, you can use the notebooks. It's similar to Jupyter notebooks, and using Python SDKs or Python language, you can write any machine learning code. So this is for mainly for the experts, and this is good for non-experts. So in the automated, before using the automated ML, that we have to create a compute. So I have created that also, as it might take time, but I'll show you how to create it. And in the compute instance, we have to select if we are using if you need high performance, that we can use GPU, but for training purposes you have to give a name, and then you have to select CPU. And from the selected options, I will share some guidelines for this, and mostly you can go through the AI 900 course, and the same steps are available there, so you can go through it and do it. I'll share that with you all in the uh, Azure Learning Center, Microsoft Learn, and select a standard. The compute section. Give me a moment. Yeah, we can select it and create. So if we are using, we can select this from here and then create. And while creating that, you can create a cluster also. So we need to have another cluster. It should be dedicated CPU again, and then same compute. We can select from here the same option, and then we have to go to next. And here we have to give a name. And the minimum number of nodes, it should be 0, and we can maximum we can give 2. And for the seconds, idle seconds, we can give it to 120. And then create. And make sure when you are doing this for testing purposes, if you don't need them again, delete them, clear off all the instances that you have created because it's very costly. And once that is done, we can do the explore in data. So in the data sets, I have imported here, but I'll show you how to create data sets also. So in my case that I'm going to select from local files, and we can select from the data store and from web files or from open data sets. So I'll create it from the local files and give it a name, and the data set is there, and uh, we have to give a name and the data store. So when we are creating the workspace, we got created a blob store also. So we can keep it as it is. And if you need to create a new store, we can create it from here. I keep it as it is. And we can then upload a file from one of the files that we have and keep the upload path as it is. Don't select this one, and you can then go to the next. And then file format, it's delimited, uh, and then comma. These things I keep as it is. And column headers, I'm going to select only first file has headers. Skip rows, I'd select none. I'm not selecting any of these and go to the next. Apart from this one, I keep it as it is. And then we can create it. So the data set is also created. And then next one, then we have to go to the automated ML. Before that, we can check if our cluster and the compute is created. it's been created, so we can use the previous one that I have created already. Okay. So here I have created, because it might take a little bit of time. So that's why I have created one already to show you how it looks. But I'll show you how to create one also. So if we go to the create data set, we can select the one I created now. And we can create a data set from here also, not only from here itself, we can create one. And then click next. So we have to select create new, and then give a name for the experiment. Demo bike rental. And target column will be rental because it's related to some bike rental data set. And the cluster, we can select the one I created earlier. So this is it. And then I say and then we select the regression, not classification, because it's kind of numerical data sets that we are having. So it's a numerical prediction that we do. So we select this and then give additional configuration settings. In the additional configuration settings, the primary metric would be normalized root means. There are some other things also. You all can search on this. And then this should be selected. And then the blocked algorithm. So there are some algorithms given. So out of this, that we can select what algorithms we want, and we can add the blocking algorithm. So for this purposes, it's selecting only the random forest and light GBM, just to make sure that the experiment won't take much time, and blocking all the other algorithms available. So exit criteria. So here it's 6 means 6 hours, but the minimum value we can give is 0.5, 30 minutes. And the metric threshold, I'm giving it as 0.8. The threshold is if the model if any model achieves this threshold, the experiment will be ended. So that's why we are giving it. So we'll save them and view featureization settings, and we have all these features available. So if we need to remove anything, that we can do it and click yes. So it will take about 30 minutes to run this one. So the status, you can see it from here when it is started. It's not started yet. And if we go to the other one I have created, now it started running, so it will be completed like this. Once it run, it will take some time, so I'll go ahead with this one. uh, yeah. So in the models, that it shows all the combinations that it has run and the normalized route and how many experiments that it has run, we can see it. And when we go to here, we can see what is the algorithm. They have the best model. The best model out of these, they have selected based on the this value. So smaller it is, the algorithm fits well for the data set. So this is the best algorithm it shows, and we can go to that and see. We can go to metrics, and we can get all the charts we can include the predict and true residual and see. So if this actual value and the predicted values goes in one line, that means the algorithm is good. So it should be mostly equal. So not all. It is not possible that it will be 100%. There cannot be 100% good models. So if we have something like that, that means there's something wrong with. We are going to make sure that everything fits to our predictions, and we might have done something wrong there. But mostly if it goes closer to each other, 95% or something, like it's a good model. So once this model is built, um, we can uh, deploy it. So how to deploy it? Deploy it and use it for any system that we want, any service. We can deploy it as a service and do it. And I'll show you how to deploy it also. Uh, and if you go to endpoints, no, we have to go to here. Then we select this one. Then we have this. And then we have this deploy button. And we can give a name. And I'm going to use container, not Kubernetes. Enable authentication selected. And then click on deploy. It shows running. Might take a little bit of time to do deploy. Until then, do y'all have any questions?
Seems like all clear, right? Yeah.
Okay. So once it is done, it would come to this endpoint, and then we can use it. Yeah, I'm not sure whether it's available yet. No, not yet deployed. Yeah, that's basically it.